I'm happy to present to you some challenges in the machine learning area and the public sector. My name is Holger Pannhorst. I'm leading a functional department in the data and analytics field in the Bundesdruckerei. I'm with Bundesdruckerei since 3 years now and have a background the last 15 years before I was in the startup area and was always connected to data and especially also to data science. Our team consists not only about data scientists, but we have a full data engineering, data analytics, and data science department with also a lot of focus about NLP. That's why I also have been invited, I guess, today to talk to you today I brought to you also 3 challenges around NLP topics. It's my first time on your conference. I heard it is mainly technical. I brought to you also some technical stuffs, but don't expect a talk like, for example, my previous speaker who was very technical. But I'm here backed up with 2 of my colleagues, also developing one of these products, which I will be presenting, and I'm happily also to connect you afterwards. And they are my joker card. They don't know about that, but when I cannot answer any of your technical questions, they can. So I brought to you 3 chapters only. One is very short about Bundesdruckerei and what we are doing, because who have heard about Bundesdruckerei and what we are doing? Who's familiar? Oh, a lot. What do you know what we are doing except printing identity cards and values? Okay. So yeah, we are doing more than that. And I will try to bring you a little of bright light into what we are really doing behind the curtains. Then I brought to you some overall challenges which I observe in the public sector and a flashlight on machine learning solutions, especially with a focus on NLP tasks. So, Bundesdruckerei Group. No, I am not a sales guy, and I will not bore you, but still, we are 4,500 people already. The majority are working, as you can see, in the identification systems. So everybody from you has one of our products in his portemonnaie. Sorry, my English. You can help me. We are printing not only passports, identity cards, and all that stuff, but also all the money is printed by us. But through that, we were enabled as a company who is from the printing perspective. We are a company since 250 years. We came also into all the technical stuff for proving, for example, is your identity card a fraud one or not? And we came by that more and more into this software developing, but also hardware developing. We're also in the cybersecurity very much. And yes, we have also tons of patents, but these one are majority in the printing area. I brought to you some of our target markets and customers. So yes, I mentioned already that we are working a lot for the central banks. But what is potentially new for you is that we are also in the health market, that we are in the critis, that we also work a lot with federal governments and federal ministries. And this is due to our background that we are under the surface of the Federal Ministry of Finance. So Christian Lindner is mainly my boss, my biggest one, not him directly, but through that we have a deep connection in the public sector. Okay, now we come to something more concrete. So what is the public sector? Who have worked in the public sector already? Not some, yeah, that's good. Who have implemented machine learning solutions in the public sector? Okay. Happy to connect to you afterwards. And for the majority of people who did not do that, so what's the major overall challenges which we have to conquer? One, and the biggest, and this is also what Bundesdruckerei stands for, is security. I mentioned cybersecurity, but security in general is one of the main requirements to process that with all what that belongs to. BSE certification, there is a ton of, let's say, tons of things to respect before we can even implement something. This is also, we are just currently evaluating more and more the cloud. Before everything was on-prem, and this is also deeply connected into the security area. The second biggest challenge in the public sector is about explainability. We are working with a lot of federal ministries, and hallucinations, they don't like it. Whatever that means, but they don't like it. And when I say that accuracy is not the most important, I really mean that. And not everything should be explainable, but if you heard about the AI Act, we need to respect also that. And we as a Bundesdruckerei, with our solutions, we want to create also trust. We are trust and security. So coming maybe to something more specific. So our customers, when I speak to the customers in the public sector, are mainly federal ministries, and they have a lot of text data. A lot of text data to understand, to read, to digest, to answer even in text. And they have so much text, sometimes they don't even know where to search for. And sometimes it's best to ask a colleague where to find the information. And that in the year 2024. It's stunning. So they have a search optimization, search for information optimization problem, which is very, very interesting to solve and to tackle. And they have an efficiency problem like every company has. It's hard to be in the recruiting area, especially when you recruit for civil servants and all that area. And people, I will talk to this in a second, when we can reduce manually work, they can focus on really actions which we digest out of the data. So efficiency is also a big thing for them. Right now, I brought to you only three machine learning solutions in the public sector. The first one is an extractive summary or an extractive summarizer. When I just said that the people in the public sector, they need to read a lot of text and understand a lot of text, and that they do that manually, there's people who are marking. Some people of you have studied potentially, and when you read a lot of text, you have like a marker and you mark the interesting paragraphs, the interesting sentences inside a huge document. And believe it or not, people are paid for doing that. Inside, I don't want to blame somebody. This is not about blaming, okay? This is just about understanding the status quo. There's people who are manually marking with a yellow marker the interesting paragraphs inside a huge text document. Okay. Some people already think about solutions. And yes, we worked on a solution and we have been implementing a solution. But as I also said, the majority, they don't like hallucinations. So we have different solutions. This solution is strictly forbidden that we hallucinate or that we deliver contradictory information. How do we do that? So, as I said, we have some algorithms for topic modeling. The majority of people potentially know them. We have also BERT topic for fitting text to general text summary on a specific topic. and we have the text rank algorithm, which it's Google's algorithm about page rank, stick together for algorithm for summarization. And through that, we are able to create reproducible, non-hallucination text summaries, which are imitating this yellow marking. Bundesdruckerei is sometimes very restrictive in information which I can share, but I even could share some architecture design. So we have on the left side, from your side, we have all the text, can be any document, can be even a copy-paste email, can be an article, whatever it is. We are working agnostic. And then we have this agglomerative clustering, which is splitting the text into semantic clusters and topics. And for each of these clusters, we make the summarization, and then we are ranking the most important ones, putting you together. So you can give us any text, any document, you can choose the number of topics we will extract, but we also propose amount of numbers, and then we give you the original text plus the summarization put together, so that the people don't need to read the full one. They still can do that. They don't need to rely on our solution, but they have an assistant which helps them doing their job more efficient. The second one is connected to the question, they have so much information, they don't know where to look for. And the second one is about a LLM empowered knowledge question answering system. So this does not hold only for federal ministries, but this can also be in any enterprise level. I mean, even us at the Bundesdruckerei, we make use out of this solution. But the problem is still the same. The problem is we have a lot of hidden knowledge. It is somewhere, we know it, but we don't know where it is. It's difficult to search, must stay for sure internal. And as I said, and it's not a joke, but it is like this, it's often easier to ask a colleague. So we implemented, we used a standard LLM, and yes, it is implemented on-prem, so we are not using anything which is working in the cloud until we have solved the security problems around that. And we implemented a retrieval augmented generation architecture around that, a RAG system, which gives us the relevant information via good chatbot optimization. So you can chat with your knowledge base, whatever it is it a Confluence, is it whatever it is. We implement a solution which is optimizing the search and summarize the internal knowledge so that we are able for you to extract the most important information of large knowledge databases. A RAG system, I don't want to bore you, but everybody from you, I guess, they know about how that works. RAG architecture is you're not just prompting, but you are prompting with a query. And through the query, you find the relevant information in any data source. And then what you're doing is you are enhancing your prompt statement with the most relevant information. And through that, through the LLM, you get then a generated response for your specific topic. That one is hallucinating, and faithfulness and all that stuff we are just encountering. Because as I said, one necessary good is explainability. So when you want to understand where we are doing research, it's in this area. And of course, through our partners, they help us understand that, because this is a topic which is, I think, not solved yet, but certainly a very interesting one. The last one which I brought to you is, we are working in German. You might hear that from my very unprofessional English. We are working in Deutsch, I would say, mainly. And so our products also have German titles, and TAAS, yes, AAS is as a service, and text. But in German we say Textanalyse as a service. So we develop also a product in-house. This is very new to the Bundesdruckerei, that we are not just only doing projects for external customers, but that we are also really investing a lot of money into products which we believe in. And the thing is about the employees in the public sector, they have, as I said, a lot of documents to process every day. They are long, they are confusing, the relevant information is not quickly there. Finding documents with similar content is very difficult, and the classic keyword search does not work well, especially for searching in long documents. I don't know how much you are in the political area, but there is something which is called parlamentarische kleine Anfragen. Whom of you have heard that? Oh, surprisingly, a lot of people. I did not before I encountered the Bundesdruckerei. Parlamentarische kleine Anfragen, it's written down questions to the government. They need to answer whatever the opposition is asking them. And they have a time restriction to answer that. And the first question when a new parlamentarische kleine Anfrage is encountering the question is, which federal ministry should answer that? Is it the finance one? Is it the justice one? Who is it? So our system can process these documents. Of course, first of all, when we have a new parlamentarische kleine Anfrage, we're doing some named entity recognition for metadata generation, but we are also identifying who is the leading federal ministry which needs to answer that. We are also checking because the parlamentarische kleine Anfragen, they exist since years, and they are digitalized, and we even try to help them. Is there already an answer to this topic? Was it already asked? Because who knows what 50 years of governments have answered? But it's still interesting for your current answer. It's understand what was in the past already answered. So we are looking for relevant documents for you to answer that. We are identifying the leading ministry who is answering that. We are also identifying the relevant paragraphs in this document. And this one, we are doing also all LLM-based. I said Bundesdruckerei is sometimes very restrictive with information. From this one, I didn't bring you any architectural design. But speak to us, find out more about that. My colleague, he's also developing there, is sitting over there. So you have a huge potential to speak to us. Jona is with us. And this is, I don't know if I have more time or not, or if I blew it up already. I think I'm very good right now. So that's what I wanted to bring you. Happy to chat with you also afterwards. If you want to connect to us or find out what we are more doing except NLP tasks, then feel free to chat with us. We are also reachable via email. Thanks a lot, and have a pleasure catching you.
Yeah, we will straight continue with the second half of the talk. And first, thank you very much, Holger, for the first half. And as Holger already mentioned, Bundesdruckerei has some requirements about confidentiality, and hence we can't, as we ideally would like to talk a bit more about the details of some of the projects Holger showed us, but we wanted to bring you more concrete real-world insight into a project from the public sector. And this is as well related to a task that Holger mentioned a couple of times, which is search. He highlighted multiple times that this is super important for them. And the more technical people between you will, of course, see, the technical foundations are likely very similar. Hence, I'm talking a bit about semantic search in a very specific use case for detecting business branch codes. And this is as well a thing from the bureaucracy. So when someone is registering a business, they have to give a description of the economic activities they perform in this business. And this is then used when you kind of fill out your business registration form to attach a little label to it to assign a so-called business branch code to this. And there is a long document where all of these details are written out. And here is an example. Here on the left, you see kind of a text or PDF form of what you have to fill out when you're registering your business. Here in red is please fill out all the details what you're doing. And someone might put in there, I have a used car dealership, and then here is the official document. It's a super long and thick PDF with almost 1,000 pages, and then you go through there and you find the right part of it, and then it says, okay, trade in used motor vehicles with a total weight of 3.5 tons or less. So this would be the match. So this is kind of a search task, but you see already there is a certain challenge to it because the way of description is very different. The language that is used is very different. But these business registrations and this assignment of these codes is kind of quite frequent and happens quite often. So about 600,000 businesses are registered in Germany every year. This application was done very often, like actually manually. So you would go somewhere or you would fill out a PDF and then you would kind of send it to your local authority. But it's happening more and more that this is digitized, and then there are online platforms for this. You have a kind of online process where to do it. And this assignment of the codes, that was usually done kind of by hand. So by a person that kind of knew sometimes more, sometimes less. This scheme has read this big PDF, and then they would go through it. And of course, the important ones people would know from their head or still know from their head and would write it there. For the more tricky ones, it's not so much the case. So this is like a huge manual effort to kind of make this matching. And there was as well a search application for this official document, but it was keyword-based, didn't work super well. People were not so super happy with it. So the goal was then, of course, okay, let's develop a system that suggests the best matching business branch codes for a business just based on the text description that is done by the person applying for doing this registration. Yes, and this is, as I said, you can formulate this as a search task. So, and the general document search task is, okay, you have a search query, find the best fitting documents for the search query in some collection, in some database, some base documents, and return the most important ones from them as a ranked list. And in our example that we had before, this looks in the following way. So someone would put in here, used car dealership, and then the algorithm takes all the this big PDF. I didn't show it to you, but which is there, or the text foundation, and then picks the most important documents there, or pieces of text, or chapters, or however you want to call it. We use document here in the talk as a general term. So, and then here you see the one that I showed you before, trade in motor vehicles with a total weight of 3.5 tons or less, and then this comprises wholesale, retail, and trade brokerage of new and used motor vehicles like passenger cars, including special vehicles such as ambulances, minibuses, etc. And so forth. Of course, there's the same version as well, but then the vehicles are way more than 3.5 tons, and then there are some other things that might as well still be relevant. And the same challenge still applies here. It's very different language. No word that appears here. So usually that's the way how text search works. And so one of the big challenges is, okay, to overcome this gap between informal and technical language. And I want to make a very, very brief introduction, recap, overview now about semantic search, kind of while presenting this this application. And keyword search is what, that was too much. A keyword search is, what was used for many, many years and was super, super successful. The idea is that you match exact words and phrases, but it's not just an exact match as if you would press Control F in your Word document. But actually what is used are statistics, like there is a calculation between the word overlap, which words of your search query are found in the document, then the word frequency is taken into account. It's checked, is this a very common word, is it a very specific word, and with all of this there are ranks calculated to kind of judge which documents are important or not. Important here is that there is no understanding of the relations between the words, of the context or the semantics. I mean, similar words can mean different things. Order can be very important. If you travel from A to B, it's something very different when you travel from B to A. So there are clear downsides of this approach or limitations. One things that are pretty nice and that are worth mentioning are that it's super fast, and what is maybe a pro and a con is that there are no assumption of the underlying text basis so much, so you can just plug in your documents and you're ready to go. Yeah, and this has served us for many, many years as a super good search technology, and now machine learning is kind of coming around and changing the whole game kind of. And the idea for semantic search is that you understand the meaning actually behind the words. That's what semantics are. The query document relevance is calculated by a trained and fine-tuned language model, and I will go a bit more into detail about this. The promise is true, so it understands word meaning and kind of intention of sentences, and hence often can provide better results. It has, of course, a much higher computational complexity, but I think maybe the important, one very, very important point for this in general, but as well for our application I'm talking about, is that it can be optimized for a specific task. So hence you train a model, you can specialize and focus very, very narrowly on a certain task that you want to solve for search. And this is kind of a very, very general overview. So you have, again, the search query I was talking about a few times, the collection of documents. You create some vector representation from it. You calculate similarity scores by just building a dot product. For the non-technical people here, it's a simple operation between math. And then in the end, you get your scores from it, and then you just provide your ranked list. Partly, this picture actually holds true for the keyword search, because what you there do is you create as well some vector representations, this statistics of counting words and stuff. You can make big matrices and make the lookup fast, but these are details. The important thing is that these representations are done by some kind of language model. And now a very, very brief overview how this is done. So the idea is that you want to transform your text into some kind of mathematical representation. And like the first very big breakthrough in this general idea of adding semantics to computational systems that understand languages come from the idea of word embeddings. And what you do there is we just focus on words. We're not taking whole sentences, we're picking words, and people look at vast amount of texts and then analyze in which words are very close usually to these words. Maybe we pick the word banana, and then we look at gigabytes and terabytes of text, and then we see, okay, when we talk about bananas, then it's often quite like the area around the word where the banana is often quite similar to the text area around the word apple or the word cherry. And hence you can kind of get this kind of clustering that I wanted to show here in this neat little pictures. And you can kind of get some word meaning structure in these embeddings. And this was super, super successful, and people kind of developed this further. The very important thing about the word embeddings was that they still were on a word level. So you always have the same embedding for the football no matter what was the sentence around this word. So people moved over to whole text embeddings, and the idea is there that you do something quite similar. So you first have a machine learning model, a so-called transformer model. Usually it's kind of the same technology that's behind ChatGPT and all the super large language models, but for this task, people usually use encoder-only models. It started with the BERT model, and then you can use any other bigger version of this kind of encoder models if you fancy. And the idea of, let's say, this block here, now for the bit less technical people, is it does basically the same thing as the word embeddings, just for a whole sentence. So we create mathematical embeddings for a whole sentence, and the embedding for each word is dependent on the context where it appears, so from the words before and afterwards. And then the super important idea for the, let's say, now coming back a bit to search and text similarity, and is that you kind of need as well some way to let the model know, okay, what do I now consider as similar? And this is usually done, the most simple way is by having sentence pairs. So you take, for example, a query. There was a large data set compiled by Microsoft. They took actual search queries that they had, and then they had a lot of examples of web pages that might be relevant for this search request. And then they made labels. Okay, we have this query, this document is important, this document is important, this document is important. And what you can then do if you have these sentence pairs or query document pairs, or you could even take question answer pairs, you feed them kind of both, like one for the query, one for the document, you feed them, or one for sentence one for sentence two, you feed them in your big models, calculate your representations, and then you force the machine learning model to make them equal when you build the dot product. That was the math stuff. And that's kind of how you have a supervised training of a sentence similarity task. And this works super well. And this is still the foundational idea about semantic search and text embedding models. People have come up with other ideas how to make it a bit more efficient, how to use unlabeled data. But if you now hear from, there is this text embedding semantic search API from OpenAI or from any other provider of some semantic search services, basically this is what's happening in the background. And then the question is, when you have this thing and when you want to build now an actual search application, so you have a web page, you have some kind of service, or you have now a very specialized application, as I have explained to you in the beginning, what you usually start is you start with such a general purpose text embedding that someone already pre-trained, and this is kind of the first thing. If you want to do some of these projects yourself, it's the first thing that you should do. So take one of these kind of general purpose text embedding models that is already trained and use it. Now, coming back to the task about the business branch codes that I explained to you in the very beginning. So this makes sense, but it's not as good as we would like it to be. So the way how we measure the performance is the recall at 5. That means if you make a prediction, give 5 examples of what the search model suggests is the correct one that you're looking for. Is it actually in this top 5? That means recall at 5. And this, when you take this off-the-shelf models, is at 60 to 70%, and this is not good enough. However, our big luck for this project was that there were a lot of historical annotations. I mentioned in the beginning, people used to do this actually by hand, and of course it's the government, so it's recorded. It's somewhere in a big database that the statistical authorities of Germany host somewhere, and some people made a lot of effort to get to this data. And so we could use this, and hence we had this kind of sentence pairs and could do our own fine-tuning on this. So the sentence pair in this case is like the actual text that the person wrote there. In the example in the beginning, this was the used car dealership. And the other sentence that we want to be similar is like the rather technical text that I as well read out to you about cars and cars was not in there, motor vehicles and ambulances and everything below 3.5 tons. So, and what you can do with this then is to fine-tune a model, and this hopefully gives you or very likely gives you a very good search application. However, I want to take a very quick detour because we understand, of course, not in every situation you're super happy and have a lot of collected data that someone already created. Data labeling is usually quite expensive. It's very often a bottleneck. So I just wanted to give you a few pointers what one can do, and the time is really good now. So LLMs to the rescue. So the super large language models like ChatGPT, they can help you with kind of this data labeling task. Usually these models won't replace the search itself because they're A, too expensive, and B, too slow. So if you have to search through a lot of documents, you cannot just fed all the documents one by one through ChatGPT and wait for the answer. This will take much too long and will be much too expensive. But you kind of can get assistance by setting up your training process for your semantic search model. One idea that one can often do is, Holger mentioned it, sometimes you have in large document databases, people already extract keywords. They have people who attach certain labels to it. Maybe you know from which department it comes. So there is a lot of kind of metadata which you can use as weak labels to cluster documents together and build some sentence pairs. You can as well use LLMs to judge, okay, I have here now a few actual user queries. People search for this, and this, and then you can maybe use a old kind of search algorithm like the keyword search, get some suggestions, and then let ChatGPT pick maybe the 2 best or 3 best ones, or let it even give ranking numbers 1, 2, 3 to them. Another thing that you can do is you can generate synthetic queries if you have just a document. So you can prompt ChatGPT, hey, here is this document. Consider yourself to be a person in the ministry of whatever, and what could this person ask? This is a bit tricky because ideally you have some examples of what people would actually like to know. But I mean, this is super promising, and as well the big companies who are developing search algorithms like Microsoft and Google, they write papers about that this is a super easy way to train good search models and make suggestions on what to do there in the details to kind of set up your data set. Okay, but now, since it's just a brief overview, I want to jump to the conclusion and tell you actually a little bit about how it worked out for us and how it worked well, how well it worked. And this is kind of the final conclusion for our specific semantic search for business branch codes. So in the end, we could achieve a mean recall at 5. Again, means how often is the thing we search in the top 5 documents we display of 92%. People are quite happy with this. Like the top 1 prediction is not so good. A big issue is there that often these queries are a bit underspecified. So people who sell cars often are not aware that in this scheme it makes a difference how heavy the car is, so they don't add it to the description. So this is kind of inherent in the task that there is a bit of ambiguity. And these models are used in 2 different contexts. One context is the big online platform of the state of North Rhine-Westphalia, where you can do all kinds of online services and register your own business. And we have multiple thousands of requests there per day, and people put in their description and then get the suggestions. And the other one, which we think is super nice, is it was possible to get like actual domain experts on board who deal with this big document every day on a professional basis. And this is the statistical offices, and in the statistical office of North Rhine-Westphalia, they use our tool as well now. They have a specific team kind of to check these assignments, and this took a lot of time before they use it as well now and say it's super helpful. So yeah, to mention in the end, this project was developed for and done with the Ministry of Commerce in North Rhine-Westphalia and Public Plan. Good, that's it from my side. Thank you for your attention.
All right, thank you very much. So, of course, as I said, Bundesdruckerei and dida are also working together, but we have to be a little bit, let's say, compliant with what we can show to an audience. So we come to question and answers. We have 10 minutes for that. We have the first question. Maybe, Xenia goes there already. Thank you, Xenia. And you can ask your question to both. We hope that kind of your presentations bridge the gap between technical and
thank you.
project.
My first question goes to Holger about the decision you took to put on your premises and to take also not the cloud solutions. So you mentioned this. Can you maybe say more about the so it was something you didn't have another choice, or you didn't want to sit just down and wait for securities to allow you to go to the cloud?
So I tried to answer that. So a lot of that, and this reminds me also back in the times during my startup area times, is anchored in history. So it was always on-prem and it's still always on-prem. There's a lot of regulations, BSI certification, IT Grundschutz, all that must be respected. And there's also something which is called in German Verschlusssachen. So there is Verschlusssachen, VSIT. It's a very specific one. In the end, it's critical information, which is only for specific employees to deal with. And the question is, how can you make sure that once you process something in the cloud, it cannot be hijacked from the CPU, it cannot be anchored from the memory, and this is all relevant questions which needs to be solved. I was here 2 weeks ago in the station. Next to it, there was AWS. AWS, they're also entering the public sector very much right now. So they said that they will develop in Brandenburg a complete new region, which is the sovereign cloud. And they also claim that VSIT is already possible on AWS. Still, there's a lot of mindset change, first of all, needs to be done. There's a lot of, BSI certification still needs to be done. There was a whole track about the public sector in AWS, and there was the Barmer Krankenkasse, where they were also presenting. I mean, Barmer Krankenkasse, they still have also a lot of relevant information, and they cannot just process this on the cloud yet. AWS, but also we as Bundesdruckerei, we are working on solutions, and I think we will be first before AWS, but let's be surprised.
So further questions from you?
Maybe if I can then continue my question. So what is the strategy right now that you are following? So from time to time you take the newest LLM model and then you train again, or you do fine tuning, or I mean you use embeddings also. So you have to somehow redo the stuff, no?
Yeah, we can certainly not use always the latest versions. And it's not even that, I mean, we are not implementing the LLMs in a ministry. There's also the IT from the ministries itself who are then doing all the checks about a specific LLM, and then they are implementing that one on-prem as their own. For us, we internally, of course, we also tested a lot. We worked with Aleph Alpha and a lot of different versions, but also with ChatGPT. But it's a difference whether you work with a prototype or whether you have something production ready, and you need always to respect what is the security level of the data. So if there's VS, there's currently not so many systems who can deal with VS data. There is some. But yeah, our strategy, we have certainly latency to the market.
Okay, and do you have contact with Gina AI?
With whom?
Gina AI. It's also a Berlin-based Chinese Berlin-based company, because they
check to my colleagues.
They claim to be also the best in the embeddings for German language. So
that certainly sounds. That sounds certainly interesting, because yes, a lot of our data is also the text data from our customers, but also ours is in German, and the majority of LLMs are trained on English language. And so this is certainly also one thing which we are encountering, and we need to let's connect afterwards and find out what this Gina AI is doing. Certainly an interesting observation. Thanks for sharing.
My question is maybe technical. how can you ship some of the solutions you've used working with this company, I don't know how to pronounce the name, to some other countries that require different type of security level? How do you think it will be possible for you to work with countries that are maybe not in the EU, maybe some other parts? Do you think there will be problems like sticking to their own security kind of issues for those specific countries?
The question goes to me or to Jakob?
I don't know any.
So, us as Bundesdruckerei, 95 of our customers are German-based ones. And shipping our solutions production-ready to any other country, we are not yet there. So I'm not saying that it's impossible, but I say we need, first of all, to help Germany a little bit more, because we are living in 2024, and I'm happy to enable Germany, but I'm not happy where we are. But let's focus on us first a little bit.
Further questions to Jakob or Holger?
Hi, I have a question for Jakob about the training data you used for the training pairs. How many hard negative samples did you have? And also, did you experience it that when you had more of those samples that it got better? Because that's what with our example or what with our project happened, that we just add on hard negative samples and it became better, like the F-score.
Actually, this is something that we didn't find there. So I have to be very honest here that we didn't as well investigate it so much as we would have liked to do. But yeah, my interpretation of this is, since we have such a huge amount of training data, it's kind of not so relevant. I mean, my impression is, we had to filter things down, but still in the end, in the training set with positive examples where we then sample the negative ones from a couple of 100,000, it seems to be the major factor.
Okay, just enough training data.
Yeah, it solves many, many problems.